Today I just want to give you a basic introduction to solving polynomial equations. And in order to do that, I really want to identify what a polynomial is. And in this gray box here, we have a polynomial, p of x. And this is the general form for a polynomial. We have a to the n, which is just a coefficient, and x to the n, which is just x to the highest power that's in that polynomial, followed by another coefficient, and x to one less power. So this all looks a little difficult, but it really isn't. What each of these a's are coefficients, and the x's are x to certain powers, but they're all in descending order. So if we're talking about a specific polynomial, we may be talking about a polynomial such as this one here. So 2x to the third minus 5x squared minus 7x plus 5. And in this particular polynomial, the number 2 of 2x to the third is the leading coefficient of the polynomial. Any term that is an x to the third term is called a cubic term. A term that has x squared is called the quadratic term. A term that has x to the power of 1 that you don't see is a linear term, and 5 is the constant. So let's take a look at a rule that I want to talk about, and this rule is the fundamental theorem of algebra. And then this may seem a little bit difficult, but the concept is really very simple. The theorem is if f of x is a polynomial of degree n is greater than or equal to 1, that means the highest power of the polynomial, then f of x equals 0 has at least one complex root. So what this is saying is if we set that polynomial equal to 0, it's going to have at least one solution. So the corollary is what's important for us. It says including imaginary roots and multiple roots, an nth degree polynomial has exactly n roots. And the reason why this is important for us is if we take this polynomial that we have right here and we look at it and we set it equal to 0 so that we have something like this: 2x to the third minus 5x squared minus 7x plus 5 equals 0. And we go about solving this equation. The really interesting thing about it is this power here, the third power, this is the degree of the polynomial. This is the third degree polynomial, and what this means is that when we solve this polynomial equation, there are going to be 3 answers. Some of them may be imaginary, some of them may occur twice, but there will be 3 answers. The next thing that we're going to talk about is something called the zero product property. And we've already applied this in class on a limited basis. And what this property says is if we have two things, and here they are, A and B, if we have two things multiplied and together they equal 0, then one of these two things has to be 0. It's the only way we can get 0 as an answer. So out of this, we would say either A is going to equal 0 or B is going to equal 0. So we're going to use this simple property in order to solve basic polynomial equations. Now here I have a polynomial equation and it's in factored form, and this is important for us. I have x minus 1 times x plus 3 equals 0. What I know about this is that either this or this has to be 0 in order for me to get a product of 0. So that allows me to set up two equations. X minus 1 equals 0 or x plus 3 equals 0. And I simply solve those. If I add 1 to both sides here, I get x equals 1. If I add or subtract 3 on both sides of the next one, I get x equals negative 3. So I have x equals 1 or x equals negative 3. And both of those will work in the original equation. If I plug in a 1, I've got 1 minus 1 is 0 times 1 plus 3 is 4. 0 times 4 is 0. If I plug in negative 3, I've got negative 3 minus 1 is negative 4, and then I have negative 3 plus 3 is 0. And so I have negative 4 times 0, which is 0, and they both will work. So let's go to two examples that I have here at the bottom of the page. The first one is x minus 5 times x plus 2 equals 0. And here's what I know. If this times this equals 0, then either this or this has to be 0. It allows me to set up two equations. X minus 5 equals 0, or x plus 2 equals 0. Add 5 to both sides and I get x equals 5. Subtract 2 from both sides and I get x equals negative 2. Let's take a look at the next one here. In this equation, I've actually got three things multiplied equals 0. I have an x, and then I have this binomial 2 times equals 0. So out of this, either this or this has to equal 0. And so I'm going to use that fact to set up equations to solve this. So either x itself has to equal 0, or 2x minus 7 equals 0. I'm going to add 7 to both sides, and I have 2x equals 7. Divide both sides by 2, and I have x equals 7 over 2. Now the interesting thing here is that this particular root came from a binomial that is a factor in this equation 2 times. So this is actually what we call a double root. And a root is just a solution to the equation.